Part 2, equations in two variables. Equation representing a function. An example of an equation representing y as a function of x is y equals 2x minus 3. Notice if I input a value for x, I will multiply it by 2, then subtract 3, and I will get exactly one y value back out. So for example, let's substitute in 1 for x, and I would get y equals 2 times 1 minus 3, or 2 minus 3, which is negative 1. So I have the point 1, negative 1 on the graph of this function, but I got one y value out, and that would happen no matter what I plug in for x. I would get one y back out after I multiply by 2 and subtract 3. X is what we call the independent variable, and y is the dependent variable. The value we get for y depends on what we put in for x. Do the following equations represent y as a function of x? Let's look at the one on the left. If y equals x squared, if we put in a value for x, say 2, then I would have y equals 2 squared, which is 4. So I got one value out for y, and that point would be 2, 4. If I substitute another value in for x, let's say negative 2, I would get negative 2 squared, which is also 4. So the same y value, but this is a function because anything I put in for x, I'll square it and get exactly one y back out. So yes, this one is a function. Let's look at the one on the right. If our input value, x, say is 9, then y could be 3, or y could be negative 3. Either way, the x value is 9, but I got two different y values back out. So I have 9, 3, and 9, negative 3 are both points on this graph. So no, this is not a function because the same x value gave us two different y values. Which of these equations represent y as a function of x? If I have x plus y squared equals 5, one way to decide if this represents y as a function of x would be to solve for y. So I'll start by subtracting x from both sides, and I get y squared equals 5 minus x, and then take the square root to get y equals plus or minus the square root of 5 minus x. Remember, when you're solving an equation, if you take an even root, so the square root, fourth root, sixth root, etc., you need to include the plus or minus in front of the root. So now if I substitute in a value for x, let's say 1, then I would have y equals plus or minus the square root of 5 minus 1, which is plus or minus square root of 4, or plus or minus 2. So I used one value for x, 1, and I got two different y values back out, 2 and negative 2. So no, this one is not a function. Let's look at this one. X squared plus y cubed equals 9. I'll start the same way, solve for y. So I'll subtract x squared from both sides, and I have y cubed equals 9 minus x squared, and then take the cube root of both sides. Now, when you take an odd root, you do not need to do the plus or minus. An odd root is either positive or negative, not both, like an even root would be. Now, if I substitute in a number for x, let's say 1, then I would get y equals the cube root of 9 minus 1 squared, which is the cube root of 9 minus 1, or the cube root of 8, which is 2. So no matter what I put in for x, in this case, I'm going to get exactly one y value. So yes, this equation does represent y as a function of x.